Aloha and welcome to a cloudy Friday afternoon here in Hawaii. And today I want to talk to you for a while about a very exciting moment in this course where we're going to start on actual development of the iHale system. I'm going to call it the iHale system, although some of the folks in engineering would prefer that we rename it because it has too much of an overt Apple kind of vibe to it. I'm totally okay with that, but until we have a new name, I'm going to keep calling it iHale just because that's an easy way to refer to the system that we're going to develop. So this presentation is going to introduce to you the first milestone, what we want to accomplish for the first milestone for the project, and in particular two APIs that I've developed to help you guys work together, hopefully easily and efficiently. So as I spoke about at the beginning of the course, we're going to divide this project up into three basic components. The first component is a front end, what I'm calling a front end, and that's basically a Wicket-based web application. And the goal for the first milestone is that it can display the current state of our various house systems. It can also provide some simple charts which show historical trends in values for some of these systems. And then it should also, for certain systems, enable the user to invoke commands, maybe like turn the lights off or set the lights in a given room in the house to a certain level. Now, in order for the front end's major focus is presenting information to the user and then acquiring information from the user like commands and then passing them on somehow to the system. And the interface between the front end and the repository of the system and even to the devices in the rest of the house is through what we're calling the back end. So the back end actually comprises two kinds of systems. The first is a restless-based system which will use a REST API to communicate back and forth with the actual devices in the house, and it will also have a database module in it that will support persistency. Okay, and then the final aspect of the project is to build a little simulator of the house. So this will be a separate Java program that will run and that will listen on a variety of ports and communicate back and forth with the back-end front-end system according to the REST API. Okay, so that's the basic part of the system, and as you know, there are going to be 6 groups working on this, 2 on the front end, 2 on the back end, 2 on the simulator. And the front end folks are going to be really only using Wicket because they're going to be able to just interface to a back end system for the persistency and the RESTlet. Back end folks have to know RESTlet and Berkeley DB stuff. The simulator folks need to know RESTlet. Okay, so there's 2 APIs that we need in order to make these different systems work together easily. The first is a REST API that's going to specify the HTTP protocol used to communicate between the house systems and our iHale software. Or in the case of what we're doing right now, the simulator of the house and the iHale software system. And that's specified via a wiki page, which I'm going to show you in a couple seconds. The Java API is going to define the way that the front end and the back end within a single Java program work together. Okay? And that's actually specified by 2 things. It's specified by some Java code as well as by a wiki page which is going to contain something called a data dictionary. And the reason why we need these 2 pieces is because I've designed the Java API in a way that's quite generic, as you'll see. And so the goal there is that if we discover that there's a new type of system in the house, or that the aquaponics system is going to have a new kind of sensor to measure something or another, we won't have to change the Java code in the API. in order to support that new functionality. All we have to do is add and subtract entries from the data dictionary, and then the front end and the back end will know how to communicate together. So I think this is a much simpler way to support the back and forth between the front end and the back end. You don't want to have your API code changing twice a day because someone suddenly realized there's a new field that needed to be supported. Okay, so let's go on to the demo, and I will show you each of these things. What I want to start with, I think, first is the REST API, and it's on this page here. And maybe just for grins, we will zoom in to make it a little bit bigger. And maybe one more. I don't know, that might be too big. But at any rate, you should read through and study this page, but I'm going to briefly go through it so you get a general idea of it. This is the table of contents. We have an introduction. And as I've said before, the idea here is that we're going to support two kinds of communication. Communication of state information from a house system like aquaponics to the iHale system where it can be stored and analyzed and so forth. That's one kind of communication. The second kind of communication is the iHale system instructing a device in the house to do something. So you might imagine the iHale system wanting to tell the house to turn a light on or turn a light off or something like that. So we have those two kinds of communication. We're assuming that everything is occurring over HTTP so that all house devices have an IP address that we can use. Okay? And furthermore, we know that in the case of the electrical systems, PV and energy consumption, that we'll be using E-gauge energy meters. For other systems like water or lighting or aquaponics, security, we will probably have some kind of Arduino board that we'll be communicating with. Okay. The next thing I want to go over is that there's the question of who's initiating. So with HTTP, right, there's always one computer that's making a request and another computer that's making a response. And so there's actually, when you have a house system like aquaponics and the iHale software system, there's two choices. Who's going to make the request and who's going to respond? We could have iHale making a request and the house system responding. Alternatively, we could have the house system making a request to the iHale software system and the iHale software system responding. Okay, I'm calling it either iHale initiated communication when iHale is making a request to a house system, or I'm calling it device initiated communication when the aquaponics system itself is actually sending some HTTP request over to the iHale system. Okay, both of these are valid ways to communicate. In the final version of this API, I imagine we'll probably have both kinds of communication. However, for the first milestone, and as specified in this document right now, there's only one kind of communication. It's iHale initiated communication. So in this document, when you read through it, you can assume, and it should be clear from looking at it, we're always talking about iHale asking a device either for its state information or asking a device to do something, okay, like sending it a command. And then later in some other milestone, and as the engineering side of things gets clear, we may have the aquaponics system sending some information, sending an HTTP request over to iHale. For example, if there's some bad, dangerously low levels of water or whatever, then you can imagine the device actually sending kind of an alert to iHale. But we're not in this REST API supporting that kind of communication at this point. The second thing is how is state and command information going to be represented? And the way I do that is in this REST API, which I think makes life a lot simpler for the people doing the Arduino programming, a lot simpler for people doing the rest of the programming, is that there is a single standard way that XML data, regardless of what the system is going to be representing. And this is what you can see, the state data element that always takes three attributes: a system name, a device name, and a timestamp. And then it has interior elements, one or more state elements that each take a key and a value, the key being the name of the state property, and the value being the value of that component of the state at that particular point in time. Okay? So that's what the XML looks like. It's very simple. And then we also have a piece of XML when it's the case that we're sending a command to a device, and the XML looks like this. It's got an attribute, specifies the command name, and then 0 or more interior elements providing optional values for any arguments that that particular command needs. Okay. Now note that in the case of the E-gauge energy meters, they already have specified an XML representation for how they provide state information about the state of the meter at any particular point in time, and so you won't use this XML for them. You're just going to use the XML that they're providing. Okay, so the next thing is to have some standards for talking about addressing these particular devices. And so what I've decided upon is that since we can really think of the house as being a network of devices, you know, Arduino devices, E-gauge devices, and our whatever our little computer running the iHale software system is, let's say that we have this host name suffix called halepilihonua.hawaii.edu, and that's at the end of every single host name, which is a logical or a symbolic representation for an IP address in the system. There's going to be exactly one instance of the iHale software system running on this network, and so we're going to have one IP address which we can represent that way, ihale.halepilihonua.hawaii.edu. Okay. Now, for a system like aquaponics, we might imagine that there's multiple Arduino devices potentially that are connected to that system, and so the way we're going to do that is we're going to say, well, for each device that has an IP address, we're going to name it via the kind of some symbolic representation of the device name and then halepilihonua.hawaii.edu. So this could be Arduino number 1. This could be the photovoltaic E-gauge meter. It looks like that. Okay. And then in order to specify the systems associated with that device, what we're going to do is use the context root part of the URL. So here's the way you would address the device named Arduino-1 that's associated with the aquaponics system, and here's the way you would address the device named eGauge-PV that's associated with the photovoltaic system. Okay? So hopefully that works. All right, so let's go to the kinds of commands that are supported. Now, I want to say that right now we're making a lot of assumptions because the engineering folks haven't really decided yet exactly what kinds of state information they actually want to provide about these various systems. So we're going to make some assumptions, and what I did in this document is I italicized the word assume whenever I was making a statement that I thought, you know, it's quite likely this is probably going to change in the future. But for milestone 1, let's just build a house simulator and let's build in communication that makes these assumptions, because we got to start somewhere. If we don't have some set of state, we can't make anything at all. Okay, so and you know, the way I've kind of tried to construct this is in such a way that if any of these decisions change, it's not a whole lot of recoding to fix. Okay, so what we're going to do is assume for aquaponics that we have one IP address that we use to get the state information, and we have another IP address that we use to control various things. And for the purpose of milestone 1, we can do a get to this Arduino-1 address and ask it for the state associated with aquaponics, and it's going to return an XML data structure, again, you know, using our state data representation, which I showed you above. And we got exactly 3 kinds of state that we're going to be supporting for milestone 1: temperature, oxygen, and pH. And of course the timestamp is here. Okay, so this is a GET request from iHale to a particular Arduino device, and that's what we're going to get. Okay, we have a second command, a put command, where we can put to another different Arduino device, okay, and we're going to put a value for temperature. So that's the URL that we're going to do the put command to, and then we're going to supply this XML right here, which specifies the command that we're using, set temp, and the new value. Okay, going on to heating and cooling, we've got a get command to get the state. The state is a simple single thing, just the temperature, and then we can also change the state of the HVAC system by using a put command to a different Arduino device and providing the XML here. Lighting, same kind of thing, you can get the state. There's different devices for each room, so you can address the different rooms using different devices, and we can specify the state of lighting as a level from 0 to 100, and so we get the state value back here with the level. This shows that, you know, Arduino 5, which corresponds to the living room, the value is off at this time, so it's dark in that room then, assuming it's nighttime. And then we can also change the lighting level for a particular room. Finally, photovoltaics and electrical. Here's the IP address for addressing this thing, and what I want to say is that I'm not going to document here exactly what this stuff looks like. You can just go to the eGauge documentation and see how the XML is specified. If they make a change, I don't want to have to update this page. You just consult the link. Okay? So that's the API for communicating between the house systems and the iHale software systems for Milestone 1. It's going to be between the iHale software system and the house simulator. Okay, so look through that. You'll probably have some questions, and we can talk about them. Okay, so that's that. The next thing that we want to turn to is the Java API. Okay, and as I said before, the Java API is going to consist of two things. The first being some Java code, which we'll look at here, okay? And the second being a Java API data dictionary, okay? And so let me first show you the Java code for the API, and then that will help you understand why we need this data dictionary, hopefully. So let's go to Eclipse, and the first thing I'm going to show you, this is the entire API. We have a system state entry class, we have a system state entry DB class, and then we have some other stuff here which I'll get to in a second. But the first thing I want you to note is that there's no class for photovoltaics, there's no class for water, there's no class for electrical, there's no class for aquaponics. Okay, our API between the Wicket side and the database side doesn't at all specify anything about the actual systems. Okay, crazy. All right. Let's look at the system state entry, and let's try to figure out why this is the way it is. The idea here, a system state entry class is going to provide information about the state of a particular system represented by a particular device at a particular point in time. Okay? And how does it do that? Well, it's a class where you can specify the name of the system of interest for this particular state entry, the device name, okay, and then, and a timestamp, okay, then to represent the actual state, which could be temperature, PV, dissolved oxygen, lighting level, who knows, what we have are three maps. We have a map of long values, that means integer values, but they can become very large. We have a map where we can represent strings, okay, so and then we have a third map where we can provide state information in the form of doubles. Doubles are like floating point numbers. Okay, so the trick here is that the system state entry says, given a system like aquaponics, okay, and a device like Arduino 1 and a given timestamp, if we need to represent temperature, which is an integer value, we will make an entry in this particular map of long data that says the key is something like temperature and the value is going to be a long, okay, and you know, like an integer, okay. If we needed to represent for aquaponics, you know, I don't know, the species of fish, okay, that are in the tank at this particular time. Okay, we might have state in terms of string data. So it would say, you know, the fish type is tilapia, or you know, who knows what. Finally, if there's a floating point number that we wanted to represent, like 5.2 or whatever, we would represent it in terms of the key, which might be something like, dissolved oxygen, and then the value for that might be 5.2. Okay? So our API for state is completely independent of any system and any kind of property, state property, state component that we want. It's general. Okay? So if we look through the system state entry, we can see I have a constructor where you construct it and you just give it the name, device name, and timestamp. And you got getters for that. And then you can add a component of your state if it happens to be a double by calling this put double value with the key, which tells you what kind of state thing it is. Is it parts, oxygen or whatever, and then the actual value. And that puts it in this map, this double data map. Similar for integers or longs, similarly for strings. So there's only 3 types of data that we can represent for state information in this particular API. If it turned out we needed something radically, something apart from strings, doubles, and integers, then or longs, then we'd need to actually extend the API. But for Milestone 1, this will be sufficient, and it might be sufficient for the entire thing. And then we just have a little toString method down here that prints out the data. Okay? So that's the way we represent state information in this API. Very general, very compact, easy to understand, no big deal. Okay? Except there's one problem. Okay? The problem is how will the front end of the system and the back end of the system agree on what kinds of state is going to be represented? If the front end gets one of these system state entry objects, how will it know what's in the double, what kinds of doubles are there, or what kinds of strings are there, or even what kinds of systems are there? Okay? And the way that it does that, the way that the front end and the back end agree upon what are the systems, what are the kinds of state that can be represented about each system, is via the data dictionary. Okay, so this is a document which I assume is going to evolve quite a bit over the course, even of Milestone, well, maybe not Milestone 1, but certainly after Milestone 1, and as time goes on and the engineering folks, give us more details, we will update this data dictionary to say, okay, right now, in the aquaponics system, this one Arduino device is actually going to have 5 kinds of state data. Okay. And so we'll update this data dictionary to represent, the actual components. Okay, so the data dictionary is the place where the front end and the back end are going to argue or come to agreement upon what are the kinds of values that will be in these system state entry objects. Okay, so that's the system state entry. Let's go on to the system state entry DB, okay, which is an interface that has to be implemented by any particular implementation of a backend, and it just basically implements methods like getting an entry given the timestamp, device name, and system name, putting a new system state entry into the system, deleting one. We can get entries for a particular, get a list of entries given a particular start time and end time. For a particular system name and device name. We can get a list of all the system names that exist. We can get a list of all the device names for particular system names. Okay, and then we can do this thing called add system state listener. Okay, so I don't know how many of you are familiar with the listener pattern in Java, but this is a new little programming idiom that you'll all get familiar with from using this API. The idea is, okay, that underneath, we got our backend. The backend incorporates both the RESTlet component and the database component. So the backend is communicating with the house or the house simulator. So let's say that the backend decides, okay, it's time, I want to know about the aquaponics state. Okay, so it issues an HTTP request to the house simulator. The data comes in. Okay, well, it would be nice if Wicket could automatically update itself with this new knowledge that's just come in. Okay, and so, but how will Wicket know that, in fact, the back end has just received new information about the system. And the way it can do it is by implementing this idea of a listener. Okay? So what the API does and what the back end has to implement is a method called add system state listener, where the Wicket side can define a class which implements this system state listener. The system state listener class has, you define it with the name of a system that it's going to listen for, and then a single method called entry added, which gets invoked with the system state entry that has just been received by the system. So what can happen is the Wicket side can define a listener for aquaponics, and then it can define a method that the back end will invoke whenever new information, whenever the state changes for the aquaponics system. Okay? And then that Wicket code will be automatically run and update whatever it needs to in the Wicket front end. Okay? So it's a little complicated, but not really. It's not even really a little complicated. It's uncomplicated. It's very simple. Okay. There is this database exception class. That's just so we have an exception that's specific to our particular API. So if problems occur, we're gonna not throw just a generic exception. We're gonna throw an instance of this. And then what I will do is show you this test class. Okay. This is the last code in the API. And I'll just show you that that this test class basically just defines a system, defines a device, defines a timestamp, creates a new system state entry, and then it uses these calls to add the 3 types of state data to our entry, just so you can kind of see how this is being done. And then it prints it out, so you can see it down here, and then it just gets the value to make it an actual test case. Okay, so that's our system state entry class, and that's of course not very interesting. The one part of this which is kind of new to you is this idea of a system state listener, and the fact that in our interface there's this add system state listener command. Okay, so I want to show you how that can actually work together. There's this final command called do command, which is a way for the Wicket side to tell the back end, I want the aquaponics system to change its temperature to 27 or whatever. Okay, so that's the final part of this interface. But the thing I think you're probably curious about is, well, how do we build up the entire system and use this API and show me some examples of it? So what I've done is, in addition to the iHale API project, I've also implemented an iHale API backend example and an iHale API front-end example. So you can see how these things kind of build together to produce a functional, well, not really functional system, but at least some code that compiles and kind of works together. So let's look at this iHale API backend example project for a second. Okay. Now the first thing I want to show you in this project is that there is this directory at the top level of this called iHale API, and within it is the iHale-API-jar file, which is the compiled version of our iHale API project, just the class files. Okay. That library has to be present in the back end. Okay, because we're going to be implementing this system state entry db.java interface. Okay, so we've got to have it around there somewhere. So this is added. If we go to iHale backend example, we look at project properties, we look at Java build path, we can see here it is. Okay, it's on the build path for this particular project. Now, in general, the right way to do this ultimately is to use Ivy to download a particular version of this iHale API.jar file. But I'm not doing it for Milestone 1 because I'm not quite confident yet that this iHale API class is totally right. So we're going to use kind of a temporary way of doing it where we're actually going to keep the jar file in our project directory and upload it to SVN and everything, which generally we don't like to do, but as a temporary measure to get started, we're going to do that. And then once we got a little more experience with it, it seems to be good, then I'll upload it to Ivy and we can change our build files to do it the kind of the better way. Okay, so anyway, what would a example of a backend look like? Okay, well, the first thing is it's got to have an implementation of this system state entry DB. That's the basic thing it's got to actually have. And so I've implemented this class called iHale DB, which is an implementation of system state entry. And I'll tell you, this is the worst implementation of that interface that's ever been known to man. Okay, it's or woman or boy or girl, okay, or dog. It's terrible, all right, but it works enough. For example, I threw this together in like 37 seconds, okay. I just wanted to get something that would actually compile, and then the only part of it that I actually tried to do a halfway decent job on was this idea of the listener, because that's the code that's probably going to be a little confusing to you, so I want to make sure that you understand how that works. So I don't use Berkeley DB here. I'm just creating an internal in-memory record of what entries have been added to the system that's in this map. So that's obviously totally bogus. And then we have this in-memory list of system state listeners, and that's reasonably okay. Okay, so this is where when the wicket side, the front end, wants to add a listener instance to listen for new state information coming in, this is where those listeners are held. Okay, so I got to override the get entry, and I do something silly there that kind of works but not really. I have to override put entry. I do that. Override the delete contact. That should be delete entry. Sorry about that. And then to get the entries of a certain, between a certain time, I just return everything. Okay, that's clearly ridiculously bad. Returning the system names, I return an empty list. That really isn't very good. Same thing for device names. Again, I'm just trying to implement anything for these things, just so that I get something that compiles and that can show you how this this listener design pattern works. So this is implemented correctly. So we have an add system state listener. If somebody passes us an instance of the system state listener class, then we're going to add that to our listeners. Okay. Now, where are we going to use that? Well, we actually use that when we are putting. Okay. So when we put a new entry into our system, okay, what we do is we iterate through our set of listeners, and we check to see whether the system name associated with our entry is equal to the system name that this listener is interested in. And if so, then we invoke the entry added method of that listener object on our entry. It's really pretty trivial. Okay, and that's it. It's done. Okay, so here's an example of an aquaponics listener. We have to extend our system state listener, so it's an instance of that particular class. We make a constructor for it which says that the system name that we're interested in is aquaponics, and we do that by calling the super, which is the constructor of this class, which takes a system name as its argument. And then we have to implement this entry added method, and all we're going to do when an entry is added is we're just going to print out a line that says, okay, this is the current state. Now in a actual wicket system, you'd probably update some value somewhere. Okay. So let's look at this test class, okay, which kind of shows you a little bit about how this would work. We have a new iHale DB, okay, object. We'll call it our database, and then we're going to add a system state listener to the database, and that system state listener is going to be an instance of this example aquaponics listener class. Okay. Then all we do is we create a new instance of a system state entry, which is we do in these 3 lines, and then we add the entry. Remember, when we add the entry, that's going to trigger the running of the entry added method of any listeners that we have added so far that are listening for aquaponics, or the system of interest. Okay, so let's run this particular test. Okay, and that's what you can see. The test passes, and you can see that we have invoked the entry added method of this listener, and we did invoke it at exactly the time that this particular put entry call was made. Okay, so there's how it works. Okay, we've now got the ability of Wicket to listen to things that are occurring down in the implementation or in the back end of the system and find out stuff. Okay, or at least find out that some state was changed. So that's our back end. Okay, now the last thing I want to show you is the front end. Okay, and what I want to show you for the front end is that for the front end to work, we need both the API and we need an implementation of our back end. Okay, so let's see what our front end might look like. And in fact, I'm going to make our front end pretty simple. We've got a main program, and we've got 3 listeners. We've got an aquaponics listener, a lights listener, and a photovoltaics listener. Okay, so first let's look at our main program, which is where pretty much all the action occurs. The first thing we need to do for our front end is make an instance of our back end. Okay, and so I'm going to get the class, fully qualified class name for our backend, which looks like this, and then we'll use this little bit of magic, this for name new instance thing, and all of a sudden we've now got a backend database. Okay. The next thing we're going to do is we're going to add an instance of an aquaponics listener, a lights listener, and a photovoltaic listener. Okay. So here's what the aquaponics listener looks like. Again, as before, we got in the constructor, we invoke the super constructor and pass the system name that's of interest to this particular listener. And our entry edit is just going to print out a line, something just happened in aquaponics, and it'll print out the system state entry that it was passed. Excuse me. Lights listener, just the same except something happened in lights. Photovoltaic listener, just the same except it's something happened in PV. Okay? So that's what happens here. So we're going to make instances of each of these 3 listeners, add it to our database so that when anything occurs in the back end, okay, our main program is going to, or our front end is going to be able to react to those changes. Now, okay, I'm going to make an instance of this class called Black Magic, and the idea is that this doesn't really exist, in the real front end, but this is to simulate the idea of the back end is a system which is actually receiving data from sources and so forth. So if we look at the Black Magic code, what you can see is we have a for loop from I to 1 to 10 where it creates a system state entry. It alternates between creating aquaponics and photovoltaics states, and it adds it to the database, and then it pauses for a second, okay, to pretend that time is passing. So that's all the Black Magic class does. And what we can now do, is run this main program, okay, and you'll see what happens. Well, actually, let's get to let's go through it. So after the Black Magic, what next happens is I show some other aspects of the user interface. One of which is that we can get the entries that are associated with aquaponics and Arduino 23 from the beginning of time to the current time. And so we can query the database for information if we needed that, and then we print it out. And the final thing is we can issue commands to the aquaponics system to set the temperature to 73, which would be rather hot in Celsius. So you probably don't want to set it to 73, but let's just do it anyway. And so the way that we send a command to our system from the front end is by invoking this do command method of our interface. Okay, so to see all this run, we do that. We select the method, and you can see at 1 second intervals now, this Black Magic method, or this Black Magic constructor guy is running, and each time it adds an entry to our backend database, and one of the listeners is called. Okay, and so the aquaponics listener gets called, that entry added method prints out this line and so forth. Then after that's done, we get to this, here's all the aquaponics data, which is what was returned from this particular get entries call. Okay, so you can see all that. And then finally, we want to invoke this, this do command. Okay, and then the implementation of that in our iHale DB is to just print out what was actually commanded, and you can see that's this line here. Okay, So there you have it. You have these three systems. These front-end example and back-end example are not code that you're going to actually use. The only code that you really need is this iHale-api.jar. Okay, but I wanted to show you how you'd actually, kind of sample code that utilizes this, and how you build up the actual completed system by having the back end use as a library jar file just that API-jar, and then the front end needs both the back end jar file and the API jar file. Okay, now while you're doing development, you're going to have to build, things like blackmagic.java to kind of simulate parts of the system that you don't have access to. Okay, and that's just, it's called mocking. That's what you'll have to do to kind of bootstrap development. But then as it gets close to the time for Milestone 1, we'll want to have people start publishing their jar files, and then you can, the front end can just, throw in somebody's back end implementation along with the API.jar, and everything should work if all goes according to plan. Okay, so there you have it. 2 APIs, 3 systems, 6 teams, 1 house. It's going to be great. I just know it's going to be great. Have fun.